All right, guys, welcome back for lesson 1.4. This one is about factoring. This is going to be a very necessary skill for you guys in calculus. So we're going to go through a couple different methods of factoring and just show a couple examples. In class, if you need more examples, I'd be happy to provide you with more. I can provide you with a worksheet with like hundreds of them if you really want it. So just let me know and let's get cooking. So factoring, first thing we're going to talk about is simple quadratics. So what I mean by simple quadratics is the A is just equal to 1. In order to factor one of these, what I want to look for is two numbers that multiply to C and add up to B. Note that this might not always be possible, and if it's not possible, then either A, the factors or the roots are not integers, or B, they don't exist. But if it is possible, we look at this and we say, all right, C right here is 12. B is -7. I need two numbers that multiply to 12, add up to -7, and those numbers are -4 and -3. So this would factor into x minus 4, x minus 3. You can verify this by multiplying it out, distributing x squared minus 3x minus 4x plus 12 simplifies to x squared minus 7x plus 12. So that is situation 1. So now we're going to look at situation 2 when A is not 1. So there's some different ways to do this. One of them is inspection, and inspection basically means do exactly what you did here. Just figure out which numbers go in the factors. And as you do more and more of these, that should really probably be your go-to method sometimes. But in case you can't figure out with inspection, we're going to talk about factoring by grouping. So the reason we're going to talk about factoring by grouping specifically is because factoring by grouping is something that the concept can be used outside of quadratics as well. So for factoring by grouping, what we do is we take A and multiply it by C, and then we're going to take two numbers that multiply to whatever we got here and add up to B. All right, and same note here, it's possible these factors may not be integers or they may not exist. If that's the case, you're going to use a quadratic formula. So now we're going to split the linear term into the two numbers found in part 2, and then we're going to factor out common terms. So this will probably make more sense when you see it in action. So we're going to do an example. Again, I know that I'm kind of talking through this pretty quickly, but this is a video. So if you need to pause and write down these steps, feel free to pause and write down the steps. We're going to go through the example. So right here, A is not 1, it's 6. So first I'm going to do A times C, and that is -18. I need two numbers that multiply to -18 and add up to -7. Those are -9 and 2. So I'm going to break this up into 6x squared minus 9x plus 2x minus 3. Notice that it's okay for me to do this because -9x plus 2x is still -7x, so I didn't change anything. I just changed what the terms look like. So now I'm going to look at these first two terms and factor out the greatest common factor I can find between the two of these. So that greatest common factor here is 3x. And when I factor out 3x, I'm left with 2x minus 3. In the second term, there is no greatest common factor, so I'm just going to factor out a 1, just so you can see it for the sake of this example. So this is 1 times 2x minus 3. So if you notice here, I now have 2x minus 3 in both of these terms, so I can actually factor that term out of both, and I'm left with 2x minus 3 times 3x plus 1. And I have now factored by grouping. So again, if you need some more examples of these, let me know. We're going to go through some more in class, but we're just kind of running through the basic examples for right now. All right, so I said that we were doing factoring by grouping because it'll be useful for other higher order polynomials as well. So here's a cubic that I can actually factor because of factoring by grouping. So what I want to do is I want to look at the first two terms, and I want to look at these two and say, all right, is there anything that I can factor out of both of them? And in this case, I can factor 4x squared out of both terms. When I factor out 4x squared, I'm left with 2x minus 1. All right, these two terms, so here's where I need to get a little bit creative. These two terms don't have a common factor, but my goal is to get this factor over here as well. So, and I notice if I don't factor anything out, if I just factor out a 1, this won't be the same as that factor because this is +1, this is -1. So what I'm going to do instead is I'm going to factor out a -1. And when I factor out the -1, I'm left with 2x plus 1. Now I have 2x plus 1 in both of these terms, so I can factor out the 2x plus 1. Or sorry, oh, that's 2x minus 1. I'm sorry. I was going too fast. So this is 2x minus 1. I have 2x minus 1 in both terms. And I can factor 2x minus 1 out of both terms. And then I'm left with 4x squared minus 1. Now, if I know my factoring rules, and there are a few special factoring rules that I can use, I notice that this is called the difference of squares because I have a term squared minus another term squared. So I can rewrite that as the square root of 4x squared is 2x. So this is 2x. Square root of negative 1 is 1. So this is 2x plus 1, 2x minus 1. And that is a factoring rule called the difference of squares. You can verify it and prove it using proofs, using variables. And now I look here and I notice I have 2x minus 1, 2x minus 1. So I can rewrite this in a simplified form as 2x plus 1 times 2x minus 1 squared. So now this is the factored form of this cubic polynomial. All right, so the last example, I said I used something called the difference of squares. So there are a couple different factoring things that you're definitely going to want to know because they're going to help you save some time when factoring. And these are the perfect square pattern, the difference of squares, the sum of cubes, and the difference of cubes. So these examples or these properties will help save you some time when you're factoring, and it can help you factor things much more quickly if you know these rules. So again, I'm going to keep going, but if you want to write these down, you can pause. And over here, each one of these is just an example of each one of these properties. All right, so the last thing that we're going to talk about is synthetic division. So using synthetic division to factor. So if we use synthetic division, there's a qualifier that we have to do first. Before using synthetic division, we have to find a root of the function. So for example, I look at this function up here and I notice that f of 1 is 0, meaning that 1 is a root of this function. If 1 is a root of the function, then x minus 1 must be a factor. Does that mean? Because if x minus 1 is a factor, 1 minus 1 is 0, you're multiplying anything else is being multiplied by 0, so x minus 1 must be a factor of this polynomial. So here's what synthetic division looks like. 1 I know is a root of this function, so I'm going to put 1 out here. Now across the top of this, I'm going to put the coefficients in order. This one is not missing any coefficients, but if I were, like, for example, if I were missing an x squared term, I would make sure that I include a 0 to note that I skipped a term that I don't have in that function. So I have 2x cubed plus 3x squared minus 8x plus 3. I don't need that plus there. And then plus 3. All right, so what happens here is this first term comes down. So that's 2. And I'm going to multiply this by the root that I have over here. So that's 2. And then add down this row. So that's 5. And repeat the process. 5 times 1 is 5. Add -3, -3, and 0. If I'm using synthetic division to factor, it's because I've already found a root of the function, which means this last term will be 0. Because if you remember from your algebra classes, this is from the remainder theorem. This is the remainder from the division. This f of 1 will be equal to whatever this remainder is. If I know that I found a root, it should be 0. So the reason this is helpful is because now I know one of the roots, or one of the factors, is x minus 1. And when I divide my initial function by x minus 1, I get 2x squared plus 5x and then minus 3. All right, so now what I want to do is I want to look at this to see if this factors. So one thing that I can do, if you're not sure whether it's going to factor before you start doing anything, you can try using the discriminant, which is b squared minus 4ac. Says b squared minus 4ac. If this comes out positive, then this will factor. So in this case, that is 25 minus 4 times 2 is 8 times negative 3 is 24, so that's 49, which means that this will factor. And in fact, the fact that it's 49 means that it will factor nicely. So there will be some fun way for this to factor. So let's look just at this right here, and we're going to factor this. So we're going to practice using that method of multiplying a by c. So a times c in this case is negative 6. I need two numbers that multiply to negative 6 and add up to 5. Those numbers are 6 and negative 1. So I'm going to break this up into x minus 1 times 2x squared plus 6x minus 3. And then we get x minus 1 times, I'm going to factor out 2x right here, and I'm left with x plus 3. I'm going to factor out a negative 1, and I'm left with x plus 3. I now have x plus 3 in both terms here, so now I can see that this is going to factor into x minus 1 times x plus 3 times 2x minus 1. So this would be the completely factored form of this polynomial. And you can verify all this by actually multiplying it out, and you will end up with that. So that is today's video about factoring. Today we talked about factoring quadratics, and we did a couple examples of factoring higher order polynomials. As always, I hope you were taking notes. I hope you learned something, and I hope to see you in class soon. Have a great day.